Okay, let's give you guys some more practice. But before we start, let me just quickly explain something to you first. So when you have a wave traveling through the air, um, the wavelength is inversely proportional to its frequency. So a wavelength of a wave is a distance for the cycle to repeat itself. So for example, if you look at this wave here, let's say the top is right here. Well, when will it be when the wave repeats itself? So you see this here is one cycle. So the wavelength is this horizontal distance from here to here. Okay, or you don't have to always start at the top. You can start at the bottom here. So on the way down here, so you start here, and then if you travel like this here is when the cycle repeats itself. So this here is your wavelength, the horizontal distance. Okay, let's say at the top here, travel here. This is your wavelength here, and let's say you started here. This is actually one cycle here. You see, this is also your wavelength. The thing is, this wavelength is the same as this, so it doesn't matter where you start as long as the cycle repeats itself. So if you look at a different type of wave here, let's say you start here right at the top. So this here is one cycle. So the wavelength of this one is really short. Or you can start down here, and then the cycle here repeats itself right here. You see, this distance here is the same as this distance here. So the wavelength is when the cycle repeats itself, and the frequency is how many cycles you can do in 1 second. So here, let's say let's say a wave travels through the air like this. You see, 1 second from here to here is the number of cycles that a wave can do in 1 second. The point is that the wavelength is inversely proportional to its frequency. So what that means is the bigger the wavelength, the less number of cycles it can do in 1 second. So here, if you look at this wave here, the wavelength is tiny here. So you can do more cycles in 1 second. So my point is that if the wavelength is big, the frequency decreases. If the wavelength is short, then the frequency increases because you can do more cycles in 1 second. Well, anyway, so that's roughly speaking, that's the relationship between wavelength and frequency. It doesn't matter if you don't understand this. I'm sure your science teacher will explain it to you. But here's a question here. So the wavelength of sound waves is inversely proportional to their frequency. So when the wavelength is this here, the frequency is this here. The frequency is measured in hertz. Don't worry if you don't understand this. Forget about it for the time being. So let's translate this. So here the wavelength the wavelength is inversely proportional to frequency. So let's translate that. So wavelength. Let's just use W. Other people use another symbol, but let's just use W for wavelength. Wavelength is inversely proportional to frequency. Okay, so picture this inside your mind here. Okay, and when the wavelength is 0.25, the frequency is 1360. Okay, so from that, answer these two questions. Remember, when you're given wavelength inversely proportional to frequency, when you're given something like this, you could visualize the graphs. So here, or you could visualize W equals K over X, or you could visualize W here and oh sorry, not X, F. Okay, in our case it's F, or you could visualize WF, and then as W increases, F decreases. As W decreases, f increases. So one of these three scenarios here will help you answer these two questions. Well, anyway, do whatever you want. Just answer these two questions. Press pause and have a go. Okay, so we're told that wavelength is inversely proportional to the frequency. So we can visualize this here. So I'm just going to jump to W equals a constant over F. Okay, and then they've given us one initial condition here. This one, when the wavelength is blah 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 here, and the frequency will be blah blah blah. So let's use these two figures to work out K. So this is the frequency. So put it into the F here. This here is the wavelength. So put it into the W here. So it will become this. Hang on. It will become 0.25 equals K over F. F is 1360. Okay. So now times both sides by 1360. So K equals, hang on, calculator, 0.25 times 1360 equals 340. So now we've got our equation. Y, hang on, let me clear this. We've got our equation now. Y equals 340. This was the answer before. Okay, this is a value of K, 340 over F. Sorry, this is W. So this here should be W. Okay, so this is our formula now. So now we can use this to answer the question. Find the frequency when the wavelength is blah 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 blah. So let's put this into here. So it will be 0.69 equals 340 over F. Okay. Now if you want to know F, then maybe times both sides by F. So 16 that equals times F equals 340. Because we want to know F, divide both sides by 0.69. So F equals 340 over 0.69. So that equals, hang on, calculator, here, 340 divided by 0.69. So the frequency will be 492. Let's round off to 493. 493. Okay. And question two. Find the wavelength when the frequency is this. So let's put this into the F. So this will be W equals 340 over this thing here, 982. So yeah, so we just want to know the wavelength. So let's just jump to a calculator and work it out. Hang on. So this equals calculator, clear it. So it will be 340 divided by 98. Was it 2? Well, okay, 982. I can't remember if it was 2 or 3. Okay, so it will be 0.335. Okay, so the wavelength is this. You see, even though we don't understand what's going on with the wave, we can still get a rough idea of what's going on here. All that we know is that wavelength is inversely proportional to the frequency. So just from this here, we can work out the wavelength and the frequency, even though we don't truly understand the mechanics of the waves. Okay, but we can just use our maths to get a rough idea of what's going on. Okay.